Welcome to yet another SmartQA Musings, which is a gentle flurry of interesting thoughts. And today we will probably muse about what does it take to assure rapidly. Most often when we talk about rapid, we always think about speeding up, right? And the question therefore is speeding up the doing, the act of doing, the only way to assuring rapidly? And the answer seems to be, yes, I think so. Is it? Let's ask a subsidiary auxiliary question to that. Is it really about doing more, or is it about accomplishing more in the given time? Now that's what we're going to muse about. And then probably see for ourselves that it takes probably a little more than speeding up the doing as the only means to assuring rapidly. So let's dissect it and look at it in a very interesting way. A tiny bit of math, if you will, and some physics, if you will. So we have a start, we have an end, and we have a distance to accomplish. So what we're saying is, hey, speed is basically the distance over time. And what is D in the context of what we are doing? Well, D is really the work to be done, right? So the amount of work that we need to do within a given span of time. And therefore, T is basically the distance over speed. So now, let's play with this formula. To do rapidly, that is to speed up, what can I do? I can increase the speed by reducing the time, right? And that I can do. I've got a numerator and a denominator. So the most obvious thing is lower the denominator. What does it mean? Speed up the work. And quite naturally, that comes to automation, acceleration, and so on, which is what we are normally aware of. The second part is I could play with the numerator, and that is reduce the D. And what does that really mean? It reduces the work to be done. So that means we are shortening the distance. So we don't want to do the full distance. We want to say, hey, we don't really need to do so much work. Can I reduce it? And therefore, we are looking at the context of work, right? And we'll talk about that as to what that means. And the ideal and perfect situation would be to do both, increase the speed and also reduce the distance. And that simply means we're combining those two sentences, right? Speed up the act of doing and also reduce the work to be done. So it's just a simple math to kind of set the context for what we're going to muse about in the next few minutes. So what did we really talk about? We're seemingly talking about efficiency, which is really about the speeding up the doing. But when we talked about work, we're talking about effectiveness, which is about work. And we're talking about how can we reduce the work to be done by being more effective. So when you look at these two together, you find that they're actually intertwined. So you can't really look at efficiency in isolation. So if I can be more effective, I don't have to do as much, and therefore I would have accomplished speed, right? So that's the whole thing that I wanted to talk about. Say, hey, you can't just look at it. Don't look at just efficiency in mere isolation, because they are really intertwined. Let's take this step a little further and dwell upon it in a context of what we do. So we'll take a slightly deeper look at what do we mean by work, and then kind of simplify it using simple math, if you will. So what is work? Well, the work that we probably do in the context of assurance is validation. And what are we validating? The various entities of the system under test. So what do we mean by entities? Well, at the lowest level, it could be a feature. At the highest level, it could be an end-to-end flow. So we're validating small things like features and large things like flows from different user perspectives or different attributes and different environments and so on. So what does that involve? That involves obviously testing something, right? That means testing something that is done new. Maybe it's a new feature and therefore a newer flow and so on. So what does work in the context of test and how does it relate? More the number of newer elements, newer entities, I guess the more amount of tests that we end up doing. But is work just about testing only the new stuff? Not really. And therefore, we have to add the second piece, which is about retest, or what we normally call as regression. Right? So basically, we're saying, look, we also have to, while we're building something new, we also have to ensure that the old ones are not broken, and therefore we regress the existing ones. And what is it a function of? It is really a function of the number of changes. So the more number of changes that we have done, it seems to indicate that we have to retest more associated, impacted entities, so to speak. Right? And therefore, the work really is a composition of two parts: test, which I denote by T, capital T, and retest, which I'm denoting it by capital RT. And that, in a sense, is what we are doing. Right? So now let's look at what does it take to do this rapidly. So our time that we spend on the work consists of two parts: the time that we spend for validating the new ones, and sum it up with the time that we need to validate the existing ones. And therefore, the small t is the time, the big T is that, the test symbol, so to speak. So therefore, this turns out to be the capital T divided by S gives you the time that is required to validate the new ones. And the RT divided by S gives you the time that is required to do the existing. So it's not a very complicated formula. And it's fooling around with formulas to illustrate it as simply as possible. And so when we want to reduce the total time, we can do two things. We can see how we can reduce the time that we take to validate the new ones, which is reduction of test. And we can also look at how we can reduce the time that I take to regress, and that's the existing ones, right? Technically, I can do both of them or one of them or some of them, right? Now let's drill down a little bit as to what these individuals mean: reduce time of new or reduce time of existing. So what does it mean? Now, if I reduce the capital T divided by S, what I simply mean is, how can I reduce the amount of work that I do? Can I test less? Or can I avoid doing certain tests? So which means I'm shrinking the amount of work that I need to do in test. What that is, we'll dig a little. Just wait. We'll probably talk about that. When I say test less, I'm not compromising quality. I'm just saying, are we sometimes overdoing things, or are we doing things which we should not be doing? Somebody else upstream should be doing. Maybe a development test, for example, right? Or could we do a better review and therefore do something less? That's the context of reduce capital T. We can, by the same token, we can do reduction of capital RT. And what does this mean? Regress less. So what does regress less mean? If I did not have too many issues that now we really ask, why do those changes occur? Right? And changes could occur due to a variety of reasons. One of the common reasons is fixes. So that means there are bugs that were found, we have to fix, and therefore we have to regress existing ones. And if I could have done a better job, would I have lesser issues, and therefore would I regress well? That is the context that we're exploring or musing about. Let's take it a little further. Let's look at the denominator now and ask, hey, I want to do speedier. So what does it mean to say capital T divided by, speedier test? Is there a way by which I can accelerate the speed in addition to automation? Certainly. Maybe I'm just putting a bigger word called smarter. What that means, probably many things. I don't want to explain that right away here, but I'm just kind of alluding to the idea that maybe if I could test smarter, maybe I could improve the speed of testing the new elements. On the contrary, when we look at the RT divided by increased S, it simply means I will regress faster. However, maybe by automation, for example, could be one such avenue. And we can also, obviously, just to go back and revisit, I can do both adjustment of denominator and numerator, and what you see is pretty straightforward, right? Test less and smarter, or regress less and faster. So I hope you get the drift, right? That we have got work that we've been decomposed into test and retest, and we're just playing around with some of these ideas in terms of work to be done, reduction of work, improving the speed, and so on and so forth, but both new and the existing. Now, let's switch gears a little bit and then say, okay, having kind of set the context of what is work, let's take a more systems-oriented approach to understanding the context of work itself. Because in real life, our work is not just about the current release, right? And we'll see, take a look at it, and let's take a little more deeper look, which is more expansive in nature. So this is what we were talking about. We said, look, I am working on a release, and that's the work to be done. And seemingly it consists of, as we saw earlier, two parts, testing something new and retesting something existing. And those two together in whatever model, maybe in multiple sprints and so on and so forth, the multiple cycles, that's what we end up doing. But is that all? I guess in real life, the same team is also working on some patches. Oh, because they also are available. You don't normally always have a separate team to only focus on patches. So what I hear with customers when I work with is, hey, the same team is also having to deliver some patches, and some of those patches have to be delivered now because maybe it's a field issue. So it's not that I'm completely focused on the current release. I also have patches, and those patches might require some bit of test, which is some small new additions, and of course a lot of retest because it's fixes, right? Now let's dig a little deeper and ask, there is a part which is current release and a B part which is patches. Now, why do patches come? Well, patches came because the deployed software has issues. I mean, you deployed a piece of code, a customer found an issue, and therefore if it is serious enough, they need to be probably addressed right away, right? And that's one reason. Is that all? Not really. We don't always write code which is totally ours. We use external other systems. We use dependent libraries, maybe use some frameworks. So there is a lot of dependency that we do have because our code is not just our code, right? And if those external dependencies change because there's a version upgrade, a newer library, and so on and so forth, they need to also ripple into our system and therefore not work. So the second reason that happens is, well, dependencies. So changes due to external dependencies, which we have no control of, force us to probably produce patches because some existing stuff, breaks down in real life. And the third, I have an environment in which my software is deployed, which is not external as in terms of dependency, but it's an environment which I live in. And maybe it's, the environment shifts, and therefore that's a third reason. So all I'm trying to set the context is, well, it is not just limited to current release, it's also limited to extensions in terms of patches, which could arise because of bugs in my code, which I forgot, did not find, or it could be things which I have no control of, either in terms of dependencies or environment. And therefore, there's an additional amount of work that you need to do within the same time. So now let's go back and apply the same formula to this and then ask, what does it now take to assure rapidly? This is what we talked about, right? We said that work now is no more just about test and retest. It is current work plus any patches or any things that I need to do in the same time. So I'm just giving a little bit of formula by saying it is WC plus WP, which is current and patch. And I'm sure you understand what I'm going to do next. Expand the formula just for the heck of it. So when you say WC, it is basically the test and retest of the current and the test and retest of the patch. And divided by the speed gives you a notion of performance. So I guess if you redo the formula a little bit, I guess that's what you see the next two lines. It is now each of them are individually divided, right? So it's TC/S and so on. And that's really what it is. And all I did was to pick TC plus TP as simple math, right? Now, what is important here is I'm trying to now put some meanings behind these formulas. So as you can see here, I've tried to group them in the last line by saying the test of the current plus the patch divided by the speed. If I can optimize the test TC plus TP. That means reduce the amount of work to be done from TC and TP. That could be one way of reducing time. That means, do too rapidly. Or I could reduce the RT and do and reduce the RTP and so on and so forth, right? So now I'm trying to see, what does this mean? Reduce the number of patches implies if I could reduce somehow the escapes that I have from my deployed software, which means if I could have done better tests before, certainly it's valuable. In addition, of course, don't forget, I could also increase the speed, the denominator, so therefore there is do quickly. I also could improve by doing it more quickly, and that's what this is all about. And the last one is more about doing early, and that's really what we're talking about. So I have now 4 choices. I have choices in terms of saying, can I test well in addition to doing quickly? And can I do less? And can I do early? And therefore, doing rapidly now is not purely limited to increasing the speed by doing quickly. I have choices, whatever that makes sense. And therefore, if I take a more holistic approach, I might be a little more, it might be a little more meaningful to look at how I can assure rapidly. So if I were to put this back here and then say, okay, here is an effort, which is stated as, as circle 0. That's the amount of effort. So now, if I find in that particular effort, which I have in a lot of customers, where I found that the QA folks who primarily are chartered with system-oriented test of the whole system, I find that they also are doing certain pieces of work which could have been done earlier by maybe a developer. Call it whatever you want, unit integration. I just call it dev test. So the first thing that I find is, there is a certain amount of work that is being done. That means there are test cases which are more like unit test cases or early stage development test cases, which are unfortunately designed, developed, and executed by the QA folks, which is really not the work. And therefore, you could optimize by cutting down the work, and therefore that's what it gets into one. Don't do others' work. Second, what you're saying is, okay, I am doing this work and have cut down what I believe should have been done by somebody, but then I find out that my test cases are not probably sufficient, results in therefore bugs that I find which require regression in the subsequent sprint or cycle. And if I could do a better job, then maybe I could get into step 2, which is doing well, ensuring adequacy, and therefore I don't have to regress as much, and therefore it drops further. And then now if I say, great, let me exploit the technology, let me automate, then it drops further. And then if I say, if I can leverage things where I don't have to, I have certain common strategies, certain common test cases, certain common issues, so I can actually cut down the design time, strategy time, and effort, then maybe I could do leverage. Maybe by one method could be a smarter checklist. So maybe if I can leverage certain assets, which could be code-related assets, or more importantly, test-related non-code assets, then maybe I've got the 4th way by which I can accelerate the actual testing, right? And therefore optimize and do more rapidly. So if I take this picture and flip it in a vertical fashion, this is how it will learn out. So if I were to summarize what it might take, I will start off by saying, hey, first let me do what I do well. Okay, and first I will cover my base as a QA, and then I will kind of look at automation, and then I will ensure that it is done early. So which means, I hopefully have in practice good development tests, which results in one part of shift left. The second part of shift left is pulling together certain kinds of tests which are attribute oriented early, maybe as part of even requirements review or prototypes and stuff like that. And then finally, of course, if there is a way by which I can ensure that I can do less by ensuring scopes are clear, I can leverage certain assets, and then I get to the final pinnacle. So I have a little more meaningful stepped way of thinking about the problem of what it takes to assure rapidly by looking at it from first, let me do what I do well by ensuring adequacy, coverage, etc. And then resort to automation and tools to be able to do a test more often retest in this case to regress periodically, and then ensure that the early stage tests are indeed effective and done well. And of course, the last one is any form of leverage is certainly welcome. So I've got 4 ways by which I can climb up and therefore ensure that I can do rapidly. So we talked about, remember, we started off with the idea of efficiency. We also looked at the notion of effectiveness plays a significant part in efficiency also, and they're truly intertwined. And all we did was to kind of look at that intertwining mechanism as a simple formula, if you will, and then probably arrived at these are 4 options that we have. And if all of them are implemented in a reasonable manner, then we have a better chance of actually sustaining the rapid improvement as we do, and not limited only by tooling as the only method to automate, to speeden up the system, right? So thank you so much for sparing your time and listening to some interesting thought. Certainly, this is not education or learning. This is probably just interesting thoughts that I had. I'm sure there are many more that you might have. So if you have anything that you think want to complement, and certainly share it in the chat window. I do appreciate your time to listen to this musings on assuring rapidly. Now, as an organization, that's what we do as part of transformation programs that we do in SmartQA, where we work with organizations and teams in various forms via a mix of consulting, advisory, and implementation. And one of the problems that we do solve as organizational issues is if organizations are keen, or or a specific team is keen on accelerating assurance, this is a bit of a consulting, advisory, implementation solution that we offer. So once again, thank you so much. I hope it was of some interest. I hope tickled some ideas in how you can think about assurance or assuring rapidly, because I think as an industry today, we have only, or we seem to only rely on automation and tools as the only way to speeden up what we do. But there are probably other meaningful options that can coexist and help us to do far better. Thank you so much. Have a great day.